provided already.
Yep. Now it's working. Okay. So before I start, I would like to just know one information. So all of you know about the AWS, means you have any basic idea about AWS?
Yes,
Means.
a little bit.
Mhm. Okay.
Regarding, I have gone through the cloud practitioner certification course, but I have not yet
Okay.
completed.
Okay, that's great. That's great. So, so as a DevOps engineer, we must need to have a cloud knowledge. So otherwise, it not makes sense to understand the infrastructure, workflow, the deployment models and all, because cloud itself is a platform. We discussed in the demo, if
Yes.
you remember, that's how much it is important in the market. And the creating of AWS account is actually very easy. Just try to create it. Uh, uh, just create an account AWS management console. You can just type it in the Google. Also, you can type it as AWS account create. So it will give you the first link. It's same like creating a Facebook account only. You need to give only your information, username and password, and your mail. And after that, it will ask you the credit card details, or you can also use debit card if it is in India. And it will be going to deduct only 2 rupees, and that is also going to be refund. For the validation purpose only, they will take it. Okay, just give your username and password, and then after verify it and create it. It's very easy actually. I'll also can send you the PPT if you want, if you are facing issue to create the AWS account. Once we created the AWS account, so let me take you through the first a basic understanding of networking, because networking we must should know to understand the cloud. Let me log into my account. I have created my account, and that account is root user only. Okay. So we will discuss IAM user as well, what it is. But first, we have to log in always with the root user credentials. Once I created my username and my password into the root. In your case, if you type a wrong password, it will ask you MFA. It will ask you to give CAPTCHA. So that is multi-factor authentication. Let me take you to this console. Now, if you see right side, this is my account name. Okay, here. This is my account name, and this is the region where am I, and this settings. These are warnings or notifications, and this is actual notification. This is a cloud shell. Okay, and coming to the services, all the services it will show here what are all available in the cloud. So basically, cloud is divided into the three parts.
Excuse me. This is the cloud shell you have marked in the round circle.
Yes.
But okay.
It's a cloud shell. If you see,
Okay.
open in new tab, cloud shell. It's opening cloud shell. So means it's separately creating a storage for me. Whenever you open any cloud shell, it's create your separate storage for you.
Okay.
Okay. Now this I can use it right now. So the same thing, I can also do it from my laptop CMD as well by configuring the AWS CLI. That is also shell, but we are just authenticating with the external components. So instead of you want to do in your local, or you can also do in the cloud shell. When you do, it is separately allocated you one server in this region. So this is the server IP address. Separately for you only. It's giving you one server. And this is not going to cost you. but it's create a storage for you. I'll take you to this as well when we are doing CLI things. First, so this is a console, and this side is we have a 23 regions. So all regions are 23 regions, and they are indicating with the one code called US East 1, US East 2, US West 1, like this. AP South 1, AP South 2. These are the regions actually. So in every region, there will be availability zones for this cloud. You can take also Azure cloud, you can take GCP cloud. Now, if you see, the UI will be different comparing with the AWS, Azure, and the GCP. So coming to the AWS, AWS is showing you the regions in the right side only where you are. First thing, region is nothing but you are in a region where 3 or 4 or 5 data centers are available at one place. So that is a region. For example, as I said, uh, if I have one data center, second data center, third data center, each is maintaining a 50 kilometers, and these are all maintained in one region like XYZ. So I'm calling this as a XYZ region. So now each data center, I will call it as availability zone. Okay, availability zones. Availability zone 1, availability zone 2, and 3. So each data center is a availability zone. So always zone will be inside the region. Region is not inside the zone. It's clear. Okay. Did you understand this? Zone will always inside the region.
Yes, yes.
Okay, you got it. Now let's go here. If I come to this GCP, Azure, and AWS, yes, I have regions. Azure also having regions around 163 plus. Okay. GCP also having above 300 plus. The availability zones. I'm just talking about the availability zones. And coming to region, Azure is having more than 60, and they're still increasing the count. So they are not stick to the one count. Coming to GCP as well. So they are also more than 50, but they are keep on changing the availability zones because Google is enhancing their data centers more. If you see everywhere the cloud shell, these symbols are common. Okay. Account, the same thing, help, notifications, and cloud shell. So here also cloud shell and notification settings, help, and account name, right side. Okay. And if you observe GCP UI, Azure UI, AWS UI, okay, which one is easy? Azure we can understand a bit more. Okay, whenever given, it opens the pop-up and it shows me what it is using. The valid question I would like to ask you: why we need to learn the AWS? We have three clouds, right? GCP, Azure, and AWS.
More regions.
Hmm.
Or compared to other two?
Can you just again repeat it? I missed.
It is cheaper compared to other two.
Okay. One more
More
reason.
more regions.
More no. According to the clouds, actually GCP having a more regions, and Azure also having more regions. AWS is only less. But
And it has more advanced features also compared to GCP and Azure.
yeah, if you see, AWS is having a region, less regions. Okay, fine, we will accept it. But the region expansion is more. Each availability zone is built with 100 acres. Where in case of Azure and Google, no, they are just building and connecting wherever they are taking the land. So like that, they're just looking for the locations, specific locations. But coming to AWS, I'll tell you, they are maintaining a specific strategy for data managed service backup. I'll tell you, this is a little bit more deep. We will discuss in AWS backup service. But now, general things. Now you are a customer. For example, you are a customer. Today also I met one customer who want to host his website product, is having a learning product, and he want to take a quotation which where he want to deploy, which is a good cloud to me to deploy it. He's just asking an architecture and that's come to us. Our suggestion is always telling AWS. He is going to ask me that he asked me why you are suggesting only AWS, why not Azure? Outside people are telling Azure and few people are also told GCP. Why only you are suggesting AWS? May I know the reason? Because he is paying to me and he is having a right to ask me. So I need to answer him, right? So this is my responsibility because his product I am going to deploy on the cloud. And when you are onto into the industry or when you are into the market as well, you don't know if you are very good expert in the technical skill, and you might also receive this kind of tasks or projects, and what your suggestion at that time, what your call at that time, and where you look for it. Even few applications are deployed right now on three clouds. Why they went with the AWS, why they went with the Azure, and why they with GCP. With okay, I'm not the right person to judge that this cloud is a good one and this cloud is a bad one. Okay, all clouds are good. They are using same computing technology. But the thing is, let me write down. When AWS, if I talk, it is a budget friendly first. Okay, for 1 hour it can charge 5 rupees for a server, but where I compare to with Azure, it is not that much budget friendly. So it charges 8 rupees, for example. Okay, $8. Okay. And GCP, they charge $10 directly. And this is more efficient. AWS is more efficient and reliability. Okay. And Azure, more efficient. At the same time, they are giving more security, but the charge is more. And GCP is more efficient, too much fast rather than these two clouds. GCP is too much fast. Okay. But they're charging more. One, about the budget. And the second one, in AWS, backup. Backup is managed service. And you can also use external tools. Easy to migrate. Easy to migrate in AWS. If we have an on-premises and I would like to migrate the data to cloud. So there are three types of migrations. You might not listen before, but for example, I have a data center which is too much secure. This data is too much secure to me. I don't want to trust a VPN to move to the cloud. I don't want to trust any between tool like Terraform or Jenkins to forward this data to here. So I want to be both very secure, like US government data or UK government data. Okay. I want to go with very securely. So how can I go with it? So there's a process. They will bring a trucks. We have a trucks, right, which carries a water, which carries petroleum, which carries uh, this containers. So like that, the trucks are there, same like containers. The trucks will come and they will inject the data into this trucks. Trucks are nothing but again a servers. So this truck will go to the cloud AZ and they will migrate here. They will again inject the data here. So the security is more to this truck. So when they're having a very sensitive data, so this is completely a physical transfer. Coming to the kind of automated transfer, there will be a lift and shift. Lift and shift, which is I have an application, I'm lifting it and putting it here. Lift and shift migration. Okay. And one more is refactoring, means I have application, I'm copying it into the cloud. Copy. And re-architect means the same environment I'm creating in the cloud. So these three types of migrations dead easy with the AWS. These three types of migrations I can also do with Azure, but I'll get errors because security problems. I can also do with GCP. Yes, but not budget friendly. This is one case. Second case, sorry. And the third case, integration. Okay, sorry. Integration. If when I talk about the integration, AWS is too much flexible. Okay. I have one tool. For example, I have developed one new tool. Okay. I have a good coding skills, good programming skills. I developed new operating system. Okay, like Krish operating system. So I would like to integrate with some of the past products. Past products like Beanstalk or Lambda, services architecture, containerization. I would like to integrate this. So Azure is not allowing me to integrate. No, because it is a premium version. GCP can allow, but I have to go to the permissions. Okay, permissions. I need to approach the team. I need to get the enterprise permission from them. And then I can do my marketing in the GCP. And then their APIs will allow me to authenticate. So this is the problem. So whenever a new beast coming into the market and they want to explore by adding the cloud, they want to extend their infrastructure. So it is not possible with the Azure and GCP. The possible way is AWS. So that's why AWS is having a separate space called marketplace. I'll show. Okay, so I have developed this and I would like to sell it outside, like Windows operating system or Linux operating system or Red Hat operating system. So people will don't know about my operating system. They don't trust as well. So I have to give freestyle. So to give freestyle, where can I give this operating system? The only place I have Salesforce or I have AWS. That's it. Okay. So like this, AWS is giving more advantages for the newbies and as well as integration part. Okay. Whereas comparing with GCP and Azure, no, not that much a good support. By considering this all options, a architecture will decide to move to the cloud only if they are having a big workflow applications. Okay, I have said this one. Means you might suggest me, means you might think me that I have read from somewhere else in the article. Means I know somewhere from my experience. Means I can also know somewhere from my seniors. But what I'm telling you should also believe me, right? So where can I get the proof? So there is a proof, Gartner magic. Twenty 2023. So every quadrant, means every 4 months, this company will release a report that which cloud, which vendor in every, total world, every vendor, this Gartner Magic will do the analysis and it will release a report. By this report, the market will be decided. Okay. So 2023, let me go to images and let me go to the Microsoft official page. This is in 2022. In 2022 also, AWS is in top leaders, challengers, niche players, and business. Official Azure Microsoft, they are telling AWS is holding 50% of market share. And coming back, let's go to the 2023. So we need to see in competitor website only. So itself we are seeing in AWS, then they might, yeah, they will only shows their hype only, right? 22 is there. Yes. 2023 AWS. Are you getting right? So why I'm telling AWS we need to learn? Because most of the projects are being on the AWS only. It's holding 50% of market share. That's why we need to learn AWS. Once we learn AWS, it's very simple to understand Azure as well and to understand GCP as well. The same functionality, same configurations, but there will be a slight change of naming conventions and slight change in past products. That's it. But everything is remains same. Okay. Now coming to the cloud part, AWS part. I hope you people got the answer why we need to go for only AWS rather than Azure and GCP. Clear?
Yes, Krishna.
Yeah,
Yes.
it's good.
Okay. So whatever first in the cloud, we have to learn about the first thing. The first thing is about server, because everything on the server only itself. Even I'm able to see this console in the sense server only. Okay. Let's talk about the server and then we'll move forward, understanding the regions, availability zones, creating it, deploying something into the servers. And all. So first of all, let me clear you something on the server. So whenever Let's assume this box as a server. Okay. So in many areas, people are calling this server with different name. Just don't be confused. Server is equal to virtual machine. Server is equal to instance. Server is equal to host. Server is equal to node. Server is equal to mission. Okay. So these many names, and also in some areas, they'll also call it as slave. Okay. Server is equal to this many names. Wherever they call this, just try to understand that, yes, it means server. Okay. Server is equal to VM, instant, host, node, mission, slave. Don't be confused between these names. In some area, in networking area, they might call, hey, can you just log into the node? And don't surprise with what is node. And don't search in the Google as well. When you search in the Google, it shows something. See, what is node meaning? So the point of connecting something, it will show. But technically, it is a server. So we are in technically, it is just showing about the dictionary. Okay, it's not into that. So node in the sense, it is a server. Okay. And host, mission, slave, VM, and instance. In Azure is calling VM. In AWS is calling instance. And even in GCP also is calling VM only. And where these names are coming. So in Jenkins part and Kubernetes part and Docker part, we call it as node. In networking part and Docker part, we are calling it as host. In system administration part, where on-premises involved, we call mission and slave and server. So these many names. Just don't be confused. Now, basically, what is a server? Server will have a compute engine or a compute part. This is computing part. Computing. So computing in the sense, so it is having a very clean platform. If I would like to run, I can run some binaries here. Then it can be executable here. So that is a compute part. Okay, whenever whatever the binary I can run, so it can execute, it can program, it can run on this computing part. Then my server can act like something. Okay, act like something. I'll tell you what it act like. For example, as I said, I'm having a computing part. And top of it, I am installing a binary of operating system. It can be any operating system. Okay, just OS, operating system. And one thing is clear, operating system is not a mission. Operating system is just a program that operates the mission. Okay, that's why it's just operating system. And now, if I'm running an operating system on this compute part, so this can be something. So what something? If this operating system is a Windows operating system, then it is called Windows plus server, Windows server. So if I call it as Linux, Linux server, Linux server. If I call it as something, a Mac, then Mac server, or Ubuntu, Ubuntu server, or Linux, Linux server, SUSE, okay, or CentOS, or Windows. So with the respecting of operating system, we are adding plus server name. Okay, so that it can be called with that. So any operating system. Okay, we're just externally running this binary. Whenever any mission creates this mission can only understand assembly language. Means, do you have an idea on assembly language or binary language? People know? We learned, I think, in BTech, EC, Triple E.
I don't know.
It's been
Yeah,
long.
yeah. This is like, can someone help me with that? How it is look like?
Zeros and ones.
0 0 1 0. Sorry.
It's
0
binary.
1 1 0 0 1 1 1. This is assembly language or a binary language?
Binary language.
Yeah, machine can only understand this language, nothing else. Machine cannot understand nothing. This language only it can understand. Whenever we are installing this or booting this operating system, this is also a binary. That's in a binary form. Okay, so we call on top of it as an image format. Call it as an image format. That image we are booting here, so it execute, and this binary is going to run with this language. And after this, is this not going to involve? Yes, it is going to involve more places. We'll discuss. Okay. Now, machine can only understand this language, nothing. Won't understand numbers, won't understand alphabetical orders, don't understand any calculations, nothing it won't understand. It only understand this language. And how come the servers are working right now? So the basic question, when it is understanding its only. Okay. Let's take our laptop as an example. This is my laptop, and I went to a Reliance store or any Bajaj store or any store, and I look for the demo piece first, and I liked it. Later on, what I'll do, I'll order it. The candidate will go inside, the sales candidate, inside the store, and he will bring a brand new laptop. So when he brings a new laptop, it's completely empty. Means it is just a compute mission. Understand? Okay. Just a compute mission. On this mission, you can also install Linux. It works. You can also install Mac. It works. You can also install Windows. It works. But then why people are not installing Mac on it? Just you are saying you can also, yes. The requirement of this computing part should be enough to run the Mac operating system, because the Mac kernel runs more, so it has to be compatible for it. So when how they do market means they'll only develop this computing part as per their operating system compatibility. So that's why these machines are existing. Otherwise, we could also do in Windows laptop Linux, Windows laptop Mac also. This is not a big challenge. But the thing is, when they're developing this computing part, they only develop for this operating system capabilities. When it is run, how much uh, kernel can communicate and how the binary program can execute. Okay, so when this computing is done, there should be some dependency regarding this operating system. So that should be boot. That's called boot. We need to add some repos in this computing part. It's completely a plain thing. When it is clean and plain, we have to add few repositories. Okay, we will discuss in Linux class how to add this repos as well, how this is working, how packages are installing, how operating system is coming. Okay, so this is going to happen on a mission. Okay, then it can talk with the operating system once it is booted. This operating system, I'm calling it as image. Just remember this name, image. That's it. Now, I can give you one question. So instance means
Server.
server. So we are learning about AWS, right? Let me go to the AWS. And so where can I find the instance? So just let me type instance in the search box. So I'm getting
Yes.
instance
Yes.
and instance types something. Okay. And if you see, AWS is calling instances EC2 instances,
Yes.
Yes.
right? So many people, you also mentioned you are done cloud practitioner. Did you ever done any research why AWS is calling EC2 instance? What is the meaning of EC2?
Elastic Compute
Tell
Cloud.
us.
Right. Yeah, the abbreviation is fine, but why specifically called it? Azure also
Server is
can
based
call.
on the server is based on the compute power.
Compatibility.
Hmm, so if we talk about Azure, Azure can also do the same
Yeah, but
server.
we
Hmm,
can. I think we can expand the that compute power. That's why we call elastic compute.
right. That's right. So let me tell you more clear about it. For example, I have this server and I have installed an application in it. Okay. So this server is basically this server is basically a 8 GB server. When 8 GB server, when I have installed any operating system, so its operating system will take a 2 GB from this 8 GB. Then how much it is left? It's left with the 6 GB. Okay, even our mobile also do the same. If you are took 8 GB RAM, Android system will only take 2 GB. There will be only 6 GB of RAM in your mobile. When you install application, the RAM consumes by that application. Okay. Here also, when my operating system is consuming 2 GB and I have installed application on top of it, my application is running right now and many users are logging into my application. Okay. When my many users are logging into the application, it will create some data. The process will be more here. The temp files or config files, XML files, it creates more here and it is consuming a 4 GB. Let's take an example, 4 GB, my application is consuming. So now I left with the 2 GB out of 6 GB, right? So out of, now I have announced a big sale in my application or I have integrated near future. Generally, the organic traffic will be the 50 users. Suddenly, they increase 100. When they increase 100 or increase 60 users, 10 users are adding a more data. They are uploading something, they are surfing something, they are running much more processes, much more features in the application. Like they are doing add to cart, many products. They are doing payment, okay, 2-3 times. So 10 users are actively using more than the 50 users. So what happens here? The process, the queue system inside this application will run more. When it run more, the server service also runs more. So when it is runs more, the process also runs more. The same time, the files will take more space. Okay. So when it is taking more space, this is going to consume the available space, 2 GB. Right. So it is going to consume this 2 GB. Now, when it is consuming 2 GB, And the new 10 members also coming, this 60 users also inside this application. When the storage is filled, when the space is filled, there is nothing to run, then this application will stop responding to a user. This server stops this process, stop this service. Then the application stops responding to the user. So this is completely going into the hung state, not hang. Okay, hung. Hung means it is not into responding mode to a connection. So this is the problem. How could I overcome this? Yes, I have a server. I deployed application. Fine. It is using all the 8 GB. I want an immediate expand. I want to enlarge this server. Okay. So what can I do? I can create a value. We do this lab. Okay. How to create a value. So I would like to create a value, means extra GB. I'll create more 4 GB. Okay. I'll create a more 4 GB and I will attach to this existing server with some mounting configurations. We'll call it as mount. Okay. With mounting configurations. So whenever the traffic is increased, what we will do? So we also provide this path. So it will create the files here. If something is more increasing here, then again, one more value we'll create and we'll attach to it. And here it will create. So now what I'm doing, I'm elasting my server, right? I'm elasting my server. Am I right or wrong?
Yes.
Now, server is decreasing. Server is decreasing, means, sorry, the users are decreasing here. The count is low and the process is too low. And I would like to decrease this volumes. I don't want, if the users are low and one volume is enough to me and another volume I'm attaching, why should I pay to this? Unnecessarily I'm paying to this, to a cloud. I don't want it. So I can remove this. Means I'm decreasing it. Means I'm removing it completely or temporarily. I'm just removing it. Means if let's take a rubber and hold it on 2 fingers. If you do elast, it will elast until the stretch. When you not apply the force, it will come to actual size, right? In the same way, here also, I'm elasting this server and I could also delete this and it comes to the actual stage. Okay, actual stage. So when it is come to the actual stage, I can use the same actual server. Means I'm doing elasting. What I'm doing elasting? I am doing server elasting, right? So what actually servers contains in the first? What
8 GB.
server contains in the first?
8 GB.
No, means what server contains actually?
Operating system.
Operating system I'm externally booting, right?
CPU.
What is this line?
Computing system.
Computing.
Yes, computing. What I'm doing? I'm doing computing. I'm elasting computing.
Yeah.
Yes. Where I'm doing?
Cloud.
On server.
Cloud. So that's why E, C, 2 alphabets, right?
Yes. Yes.
So on what platform, for what service I'm doing? Server. right? I'm doing it for server.
Yeah.
Server is
It-
equal to
Instance.
Instance.
EC2 instance. So
Okay.
that much uniquely is given a name to unique identify in the market. See, if we can also do the same thing with Azure, but there is a backup configurations, like we need to do some extra configuration in Azure. No, but in AWS, it's very easy to mount these things. Creating just in a 2 minutes, 3 minutes volume, and you just need to fire 4 commands, it will attach. That's it. And you can use it. So that is the advantage of using EC2. Still right now, many applications are deployed on the EC2, even though we have Docker, orchestration tools, okay, containerization services, serverless architectures, but still many applications are deployed by spot instances. I'll tell you the types of instances as well. Spot instances and on-demand instances, general instances. We have types of instances. Okay. So I think your doubt or your confusion might clear with this topic on EC2. Clear?
Yes.
Yeah.
Yeah.
Yes,
It's
it's very good explanation. Yeah.
And one more, this is my EC2 dashboard. Okay. The first thing first, everything on the server. Even though I'm talking about the technology called serverless architecture, that is also on the server. But the thing is here, you don't need to manage it. Someone will manage it. So that's why is to attract the people is telling serverless architecture. That's it. Now, so this is my EC2 dashboard, and I have sections called instance, instance types, launch templates, spot request, saving plans, reserve instances, dedicated host, capacity reservations. Okay. These are all important things. First, in an industry, let's take any industry or your company, my company, or Hemant company. Now, he want to deploy his product like e-learning platform. What would be my suggestion as an architecture? E-learning platform will get a limited traffic and it can run on the monolithic service. So I could recommend EC2 instances. Yes, I'm recommending EC2 service here. Okay. But inside the EC2 also, I have many types. Which should I go? This is one more question again.
Can you explain the monolithic services why we use?
Yeah, right now or
No problem. You can continue on that. After that, you can.
I'll tell you. Let's take monolithic like a Java application. My pen is not there. Let me go with the paint. So DevOps in the sense right now, we are dealing with completely micro. Okay. Monolithic microservices. There are two type of architectures for the applications. If you can take any application in the Java environment, .NET environment, Python environment, Perl, Ruby, Golang, can be any. Okay. There are two types only. That's it. One is mono, one is micro. Now, what is a mono? So this is, for example, let's talk about the Java application, a basic Java game application. So inside this, I have section called user. I have section called play. I have section called add cars. I have one more section called payment. A simple game. Okay. Now, when user is developed, play is there, add cars is there, payment is there. So this code is going to connect with the one database. Okay. Now, whenever a developer or we found something in add cars, this owner wants to add one more new car. Okay, which is developed in the code, testing code, and you want to add here. To add here, currently we are four, right? You three are actively using this application right now. Your three are actively playing a game here, and the owner wants to add this. Then the users can excite for this car to play in this gaming application. And this is giving on a subscription, like you need to pay for $2 or a $4. So you'll get money as well, and users can excite, and his brand can be promote more. These things like that he would like to add it. Now your three users are actively using. Even though you are actively using, you want to update. So this is not going to possible in monolithic. Why? If a developer doing this service is dependent on this user. This user is dependent on play. This is also dependent on the payment. So these connections are there. One section is dependent on another. Okay. So these four sections into a one repository in GitHub. Getting my point? This four sections code into just one folder, not individual folders in the source code. When the developers are writing the code, these are all into one folder. If they want to deploy something, they has to deploy whole repository. There is no specific option to only deploy this. Means all sections are here, means when I'm running this section, these three sections also will run. So that's why he need to take a downtime, and he will give you a warning that we are going down for 1 hour, and you three people cannot use this application that time. So he will test out and he will deploy this application one more time, and after 1 hour you will be able to see this application. This is completely a monolith, and to deploy it, you have to deploy manually by your hands. After deployed, if something was happened, if something bug was there, or your payment is getting stuck in it, so they has to roll back to the previous application. So this is the new application. They want to roll back to the previous application. Again, they have to take 1 more hour to roll back. So completely in a day is just losing 2 business hours where is getting a business, right? So this is the biggest disadvantage of a monolithic. One is dependent on another service. The best example is our Windows operating system. Can you update a paint without restarting your whole operating system?
No,
You are just updating, installing the driver, but will it going to reflect?
After restarting only it will.
Yes. Windows operating system is a monolithic. Okay. And coming to Linux.
But we are using Windows here. What is the advantage of this using the Windows operating system? Like, I'm
Windows
just
operating
telling.
system is graphical user interface. Humans are likely to uh, interact, right? So Windows is giving me these options, means writing a pen, giving these visual representations. So because productivity is more, because human wants to do something, right? They want to show something, they want to do the business. So graphical user interface is good for us. So that's why Windows is more popular. But when coming to deployment of applications, everywhere you see Ubuntu Linux.
Okay, companies are using monolithic services for graphical purpose.
No. It's I'm talking about the servers. Right now, it's a
Okay.
monolithic is inside the application. I'm telling. The
Okay.
example I'm telling is a Windows operating system.
Okay.
Okay. Now coming to microservices. In microservices, let's take up Amazon. I have clothings, footwear, add to cart, payment. I have electronics devices. I have kitchen device, means kitchen things. 6 sections are there. Each section is having a separate repository in GitHub. Okay. Separate repository. And each repository I can deploy into the different server. I can connect them by load balancer. Now, what happens when in these microservices, there are actively, we are 4, right? We 2 are actively monitoring this, sorry, accessing this cloths, okay, clothing section. And in this big sale, and Amazon got a new product and you would like to add into the application, then the user can add to cart or buy it at a time. So you don't want to down the application. You wants to do directly update it. Okay. What they will do? So which is the repository of updating this? So this is the repository of updating this. So the developer will update and deploy into this server. Okay. And it will be happening here. And when user want to see this, when he's going and clicking on this UI, the load balancer will forward here. I think the drawing is not good here, confusing manner. Clothing, electronic device, add to cart, payment, and this is something order tracking. Okay. Now this is load balancer. Each one is deployed in different server, not in single server. Monolithic, it should be in a single server only. Each one is deployed in different server. Now this load balancer is connected to this. When users are actively using this electronic devices, the new feature he wants to add here, or one user is also using here and the new feature he wants to add here. So in this cloth repository, he will update the code and he will deploy here. Okay, in a fraction of seconds or in a fraction of minutes. That is called continuous deployment. Once we deployed here, the user shouldn't experience interrupt. Okay, even these 3 users who are using electronic things, they no need to be interrupt. It has to be forward. Okay, so what happened when this load balancer is a picture? This is a server. This load balancer will responsible you to stick this server, and you can use these options. When this user is sticking on this server by this load balancer, when you deploying here, you will get a little bit latency. The page will not load to you. Once it is updated, within a second, when you refresh, it will load. That is not a problem to you, right? Just it will just giving you latency of 5 seconds or just 10 seconds. You might wait for it. It's not, but is not downing the application for other 3 users, right? Other 4 users who are using other categories. Is not entirely downing the application. He's just specifically updating one section on without interrupting other users, other services. So now microservices means this is one micro, one micro, one micro, one micro in the application. All these are communicating with APIs, REST APIs. How if I book something here, how it is coming to the pay section? Because of the REST APIs. In monolithic, we use SOAPful APIs. Okay, here we use REST APIs. Now, it is going to communicate here in a decoupled manner. The owner can also remove this, add this. He can remove this, add this. The application will not down to other users. So this is decoupled, okay, or loosely coupled. Microservices architecture is loosely coupled connections. Now understand?